Welcome everybody to AI Star Space, AI and Space. It's Thursday here in the AI house in Davos, and on the first day our topic is the next frontier. So today we want to go a little bit beyond what AI applications we have today and how we use them, and want to look a little bit into the future, do some strategic foresight, and think where will we need artificial intelligence in the future, maybe also not only here on Earth, but beyond. So I'm very happy to welcome Josef Aschbacher, General Director for MESA, Martin Maurer, astronaut for MESA, Brian Schmidt, Nobel laureate, Olivier Houllier,
the outlier,
and Bilge Demirkoz from the Metro Institute. Maybe you want to introduce yourself very, very quickly with one sentence where you say who you are, but also with one sentence, what is most important for you in the combination between AI and space? Josef, would you like to start?
So first of all, thank you. I'm very happy to be here. I'm very happy to see this full house. It's quite amazing. AI and space has a lot to offer, but maybe since you asked who I am, I'm the Director General of ESA, so the boss of ESA. ESA is the European Space Agency, 22 member states. We have about 7.8 billion budget, and we are focusing our work on satellites, rockets, and the use of data. And of course, AI and the use of data is crucial, and we can say a bit more afterwards.
Good morning, everyone. My name is Matthias Maurer. I'm a European astronaut. 2 years ago, I was participating in Davos for the very first time, connected live from space, from the International Space Station down to here. So it was a very nice start to participate here. In space, we need AI. I used it during my spaceflight mission because it will empower us. It will allow us to do stuff that we can currently not do because we depend a lot on the support from the people here on the ground. But once we venture off deeper into space, we need to have all this brain power with us, and so AI will be the key.
Hello, I'm Brian Schmidt. I've just finished being the president of the Australian National University, but I'm a Nobel laureate and helped discover that the expansion rate of the universe is accelerating and it's probably full of dark energy. So for me, AI is a powerful tool that helps us work in space more powerfully to do things we just can't do in a more safe way, especially when it involves astronauts.
I'm Olivier Houllier. I recovered professor of neuroscience turned AI entrepreneur, and my entire life I've been building human-machine interfaces with one goal, to make sure that machines adapt to who we are as a person, but also in the moment. And I'm here to talk about the human factor in space flights and how we can empower, thanks to artificial intelligence and neurophysiology, people in space during long space flights to interact better and benefit better from all the technology that is embarked.
Hi everyone, I'm Professor Bilge Demirkoz. I'm a professor of physics who worked at CERN for many years. And we work now on an experiment up in the International Space Station called Alpha Magnetic Spectrometer, where we're looking for dark matter. That was dark energy, that's dark matter. And we're using now AI techniques to do it. And I'd love to talk a little bit more about as well how we're going to use AI more as we step out of Earth into other planets as our natural ambassador in a place where communications are limited.
Thank you very much. This week now here in the AI house, we have been very closely looking at AI. I want to turn it around a little bit and basically see that we are also observed out of space, and that we're observing our Earth from space. What can we do better with artificial intelligence that we cannot do with classical algorithms when we talk about Earth observation? What are the opportunities that we have there? Josef, maybe you want to start.
Yes, no thanks. Just one quick word on dark energy and dark matter. We just launched a mission last year, as you know, Euclid, which will look into both. So AI and Earth observation, it's a huge topic. In fact, I'm very happy to say that the very first satellite, Earth observation satellite, which had an AI chip on board, was one I initiated a couple of years ago called VSAT-1. Today it's, I'm not saying common, but it's much more used. And it was actually an AI chip which we bought on Amazon for 70 euros. I'm not making promotion for any company here, but it's a standard AI chip which you can buy anywhere, let me put it this way. But of course, we made sure that it works in space. So we went to CERN, we have done the radiation testing, we have protected it and so on. But what was much more important is I said to my people, I would like disruptive ideas, innovative ideas, something that may not succeed. And telling my space engineers to produce something that may not succeed is actually impossible. We really had actually more work to do to convince my engineers that they go for the project than to actually make it. But what happened is we really trained this AI chip to do, I would say, a simple task, which you might think is simple, but it was not so, to distinguish cloud-free from cloud-covered areas, and then only send down from the satellite data which are cloud-free, and throw away all the clouded areas, so already reduce the data transmission by 50%. But of course, you can train the AI chip to detect anything, forest fires, floods, ships, whatever you want to have. And this is really the potential, that you can automatically or automate a lot of the detection using AI for Earth observation, image analysis, image processing. You may say, why do I need AI? Of course, humans are always better, there's no question. But if you have volumes, huge volumes of data, as we have it today, with satellites sending down images literally by the hour, with updates by the hour, and you want to detect changes, you want to detect something happening, then of course you need automations, that means AI, machine learning algorithms to really help you doing that. And this is a huge potential, not only to recognize features, but also to, in space, help, I would almost say, quickly decide by the satellite itself whether this is worth a further action or not. And if it is worth further action, it can be another satellite that is being programmed for another acquisition, or a ground station, a civil protection unit for forest fire, or whatever it is, in order to really be very quick and almost automated. And I think this is a huge potential. We're at the very, very beginning of it, and I think there's a lot to come.
Thank you very much. Very quick question. Do we have all the data available? Is it open, accessible? Is there a platform that collects all this, or is there more action needed there?
Actually, what we have done in Europe, and some of you may be familiar, especially in ESA, we have always had Earth observation as a main program. Climate change was a main driver of our missions and our activities. 30% of my budget of ESA is allocated to Earth observation. And there's one program called Copernicus, which we have developed over the last 25 years. All the data which are acquired by the Sentinel satellites are provided for free, open access to anyone of any place in the world. You just need to log on to our website, sentinelhub.esa.int, and from there you can, after you have logged in, you can retrieve and get images from any place in the world. 350 terabytes per day are being sent around the world for free, and I think this is our contribution of Europe to better understand our planet and therefore take good action for climate change decisions, climate impact, climate adaptation, which we need as a #1 priority.
Thank you very much. Let me turn to the other side. Bilge, you mentioned AMS, electromagnetic spectrometer at ISS. So what kind of data do you get there, and how do you use AI?
So instead of optical data, we have data of particles. So this isn't photons, which we see, but it is the unseen particles coming from everywhere in the universe. So these things could be coming from our sun, but it could also be coming from other stars. They could be coming from supernova explosions, from neutron stars that are accelerating materials from around them. So there are plenty of very high accelerators up there in space, bigger than what we can produce at the Large Hadron Collider. And I see a couple of colleagues here from CERN, so Carlos, and from Atlas. So unfortunately, the Large Hadron Collider right now is limited with its energy. And if we could go up there and build, maybe we will, build even larger detectors up there, we could learn a lot of physics. Right now, we're limited on the alpha magnetic spectrometer by the size of what can be put in space currently. So we're on the International Space Station, for which we're very grateful to ESA, NASA, and all the other partners. And we have a very good data we have very good data that's flowing from that International Space Station down to Earth, and we're looking for dark matter by looking at the properties of a particle called a positron. Now, the positron, you might know, is the positive brother of the electron, and there's very few of it. You might know it's used in PET, the PET scanners, positron emission tomography, but in space, at high energies, there seems to be a bit more of it than what we expect. And this has been shown to be a signal, a telltale signal of dark matter, but it could also be coming from pulsars. And this is something that we're still working on to understand. The signal, we have a signal, we want to understand it better with smaller error bars. So instead of using classical data analysis techniques, now we have turned to machine learning techniques. And we're using CVTs, convolutional vision transformers, which are generally written for image processing. So we've changed our data, we've modified our data to be something from something unseen to something that we can see, and we make it a photograph. We make photographs of these events, and then we apply these algorithms to separate positrons away from the background. We are now in the process of writing up some papers, hopefully. So we love these CVTs. They're doing a much better job than normally what you would expect from classical analysis techniques.
Thank you very much, Bilge. Brian, may I turn to you and ask now, we understood now from Bilge that we are looking at our universe and trying to understand its origins, but also basically its composition and its history. What kind of observation of a universe would be interesting, where you think that artificial intelligence could help us to understand our universe better over history?
So, I mean, I guess I see space as a giant potential laboratory that has an infinite number of possibilities. So let's think of something that I think might happen over the next 10 or 15 years. So we here on ground have created gravitational wave detectors where you're able to essentially see the distance between two things to about 1,000th of the width of an atom. Now, you can imagine the next generation wanting to get beyond the confines of Earth and going out into space. Now, space is nice, there's no gravity, there's no earthquakes, but there are other little things that cause things to wiggle. And unlike Earth, where you kind of have a bunch of, like 1,000 people looking at it and correcting, and sophisticated AI algorithms already, you're going to have to employ them to, in the same way, do analysis in space, because this thing generates a huge amount of data, most of which is not interesting, and so much data that you're not going to actually be able to do the experiment if you have to bring it all down to Earth and process it. So it's a very common theme, is you need that autonomy to kind of like have your researchers up in space to make things happen. But you can come up with almost any problem in the future. You can scale it up and essentially take the human necessity to be there out of the equation, which just allows you to scale up things by tens, hundreds, thousands, millions.
Thank you very much. So I understand now that basically it's really interesting to look and observe our Earth and using AI algorithms. I understand that basically for understanding our universe itself, it makes totally sense. But what is with a human factor? Maybe, Olivier, can I turn to you and ask, as a neuroscientist, with your, what observations should we do of the humans that maybe an AI algorithm should help us to analyze? What are the interesting questions that you have where AI could support us to understand ourselves better?
First, I feel terrible for one reason, is the narrative of what I've been doing with my co-founder at the Inclusive Brains is Paul and I, his name is Paul, he's half my age, brilliant guy. We don't dream, unlike many kids, to go to space. We dream about the remote control. The remote control was a device that was invented to help people with disabilities interact with a technology, the TV. The remote control not only changed the way people interacted with technology, people with disabilities, but it became pervasive. It changed how every one of us has interacted with technology from half a century. And the learning from that is when we work on brain-machine interfaces that are assistive technologies. Assistive technologies must be inclusive in a way that they help everyone with special needs, special abilities, up to the people who are the highest performers intellectually and physically. And astronauts embody this excellence. Yet, as brilliant and super trained as they are, their performance can be improved. Not only the peak performance, but the durable, the sustainable performance. Because in space, it takes time. We are looking ahead at very, very long space flights, during which there will be different kinds of interaction with ground control. Interactions and information processing that our brain are not ready or trained for. Delays, adaptation. And so far, the most advanced interaction between machines and humans are embodied for a lot of people by large language models. But language is not enough when one wants to understand how humans and machines interact. I am more than language, hopefully as a French person. I am a brain in a body that interacts with environments. So we're working on a neural foundation model. What does that mean in artificial intelligence? That we're not only training our models with words, we're training models with biological information, brainwaves, facial expression, breathing, heartbeats, neurophysiology. Because the one thing we want to be able to do is to create the best assistive technology for people with special needs, special abilities, and for astronauts. Why? Because sustainable, durable performance during space flights, space operation, will require management of mental health issues that we might not have encountered yet, even with the longest space flights, where artificial intelligence, and especially generative artificial intelligence, is going to kick in and provide something unprecedented, is that in these new situations, by integrating what tech geeks like me called multimodal information from different channels, different senses, artificial intelligence and Gen AI is going to be able to make more sense of it, be able to predict better, when to sleep, or when to bring assistance if there is distraction, or just because, I think Matthias will speak much better about it, but sometimes you got, I'm sure, nostalgia. You're missing your loved ones because there are humans at the heart of it. So the core is to provide with artificial intelligence combined with neurophysiology the most advanced and useful assistive technology. It's about assisting.
Thank you very much, Olivier. So Matthias, he basically asked the question, how does it feel to be observed very, very carefully? We have been talking a lot about privacy this time and this week, and discussed basically where are the risks with privacy and AI. As an astronaut, as Olivier said, you are very, very carefully monitored. Does it make a difference if you're monitored by humans or by an AI? Can you tell us a little bit for you what your experience are there?
Yes, so as an astronaut, obviously we're up there in a very complex machine, and this machine has a high value. So the ground controllers on the ground want to make sure that we astronauts perform, that we don't break things, that we perform as expected. And you can imagine that if there's a crew of 7 astronauts up there, and if there is a situation where there's a conflict in the team, that is not ideal, because then we will always underperform. So scientists came up with ideas saying like, okay, maybe we send you an artificial intelligence that recognizes if you're in a bad mood and it tells you a joke to cheer you up. And,
only scientists can come up with that, right?
Yeah, exactly. So I had such a machine up there, and when I asked, like, can I have my joke? It failed because the data connection down to the ground, it was connected to IBM Watson on the ground. So it was not the AI on board or the system on the ground which failed, but it was just the data link was still too thin. So lesson learned, we need to have the full AI on board with us. Okay, so but coming back, what we can do I would say, like also in other aspects, very useful with AI in space is we can take care of the astronaut health. So when we fly up there, we're in zero gravity, we have a fluid shift, which means I have way more liquid in my brain, in my head, that presses on my eyes and it changes my vision. So I get an edema in my eye. It sounds bad. It is also a reason why we... It is at the beginning moderate, but the longer it takes, the worse it gets. And it was one of the reasons why today we wouldn't dare to fly humans to Mars, because it might happen that we arrive there and we are blind. So it's definitely a problem that we need to tackle. And so we had a small device up there. It's almost like a mobile phone with a very small optical lens on top. And I had to take photos of my retina. And the retina, interestingly, is the only place in the human body where you can look directly on blood vessels. And the medical community is super excited and said, like, there we can have a photo of your blood vessels and we can actually derive from this information if you have heart problems, if you have other organ problems. In my case, if the retina is damaged due to this edema that is forming. So there's a huge medical potential that we develop for astronauts, but the application can immediately come back down on the ground for telemedicine. That's one aspect. The other aspect is a spacecraft is a very complex machine. For Saturn V, that brought Apollo to the moon, we had 300 ground controllers just checking that the rocket was in good state before they said, like, we're go, ready for liftoff. So imagine a spacecraft flying today, flying the International Space Station, flying beyond space. We have beyond low Earth orbit, I should say. We have so many ground controllers taking care of the station, and we cannot control stuff in real time if we get further and further away. So this intelligence, how to run the machine and to also act if the systems run out of their standard parameters, is definitely where we need also this AI stuff. Then air traffic and space traffic control. Currently, we have 6,000 active astronauts, active satellites in space. Satellites, and I learned we have 1.7 million filings to send more satellites up there. So going from 6,000 today to this huge number of 1.7 million satellites. Not all will be flying, but at least it shows that people are interested in bringing more stuff up there. We need to control that. It's currently we have people controlling a few spacecraft. And every time two spacecraft are on a collision track, somebody needs to say, like, okay, I take my one out of the way, but then you lose lifetime because you burn petrol. So you lose money. So, and people are therefore not interested in moving my spacecraft. The other guy can move because it's his money, but that will not work. It's an ecosystem that will only work if we find a general optimization of this problem. And this is way too much to have it done by human brains alone. There we need artificial intelligence.
Thank you very much. Josef, may I turn back to you and ask, Matthias and also Olivier have been talking about delay, and as somebody now working in telecommunications, I'm very interested in delay, because imagining now the first telephone calls between Mars and Earth and thinking about that, I say hello, and then I wait 15 minutes and then until it arrived, and then wait another 15 minutes until maybe an answer came back. Hello, who's there, whatever. Imagining communications like this makes it very, very difficult to have this kind of human interaction on a long term. So I haven't fully given up. I'm still thinking about quantum entanglement, and maybe at some point it can help us. But the hopes are very, very, very little that we can do telecommunication over that. And I see
we got a Nobel laureate that doesn't agree. Huh?
So all hopes are gone now. Perfect. But Joseph, what are other AI applications that on this deep space missions are important? What are missions that cannot be done with classical control systems on other planets, where this delay is basically forbidding to do classical control algorithms? Can you give us a little bit of an outlook into the future? What do you see there in the next 5, 10, 20 years?
No, I think Matthias already mentioned a very good example, which is collision avoidance, which is in our low Earth orbit, which is not too far away, but still where quick decisions are necessary to recognize an object, another incoming object, and fly a maneuver. And there you need a very fast mechanism. AI obviously is certainly very useful there. But let's go much further out. And if you say hello, nothing comes back for a long time. We have this situation. We are launching this year a satellite called Hera. Hera flies to an asteroid, Demirkoz, which is actually monitoring the impact of the DART mission on an asteroid, which NASA did recently. And our satellite will fly there, will release some CubeSats to go onto the asteroid or close to the asteroid and monitor. And you can imagine there's this Hera mission, which is rather large. It weighs 1.2 tons, so it's a large satellite, and it flies to this asteroid, which is relatively small, a relatively small object in outer space. And there's no way that we can, when we approach the asteroid, immediately steer it remotely, because it takes minutes, literally, for a signal to come back here, do something, and go back, or maybe half an hour, to command the satellite. So what we have is an automated camera with automated detection of the situational awareness. So basically the satellite looks around to see where it is and what it sees in its surrounding, and then makes, of course, onboard decisions on what to do and how to behave. So we are not doing it from ground. This is done in the satellite itself. Of course, we need to program the chip. We need to program the environment with all the sensors that are required. And that's an absolute necessity, because if not, there's a very high risk that the satellite simply crashes into the asteroid and is not at all fulfilling its mission. On top, we want to get the maximum out of this mission, so therefore detect the spot where it is most interesting to look at, and this you can only do live out there in space. So this is a very practical application. This satellite, Hera, will launch in October this year, and will fly to this asteroid and will perform exactly these detections and decisions based on AI right away. Of course, then you can go even further out, and everything to do with exploration. You need to interact on the spot and cannot send commands forth and back. But even for the moon, which is, of course, much closer, even there, if you imagine the future moon economy, there will be robots exploring a territory on their own. They will need to make some decisions whether now to turn right or turn left. Of course, astronauts will always be much more clever than any machine you can ever conceive, at least for the time being, conceive of. But this assistance of robots with intelligence on board, in order then for astronauts to really point them to the right direction and then use their skills in order to analyze the situation, is a must. So for us, it is an absolute necessity. We are investing actually quite significantly. I've just last week asked my directors to develop an AI action plan for ESA, where and how we can use it on the ground, in space, on the moon, and different places. It will be a major activity. It's one of the priorities that I want to develop. But also one point I raised, which is extremely important, to combine AI with ethics. Ethics, you may think, what's the ethics part in space? But there's a lot of applications. I do not have yet all the answers to it, but this is something where, at least from an ESA point of view, I really would like to use AI in very close connection with ethics.
Thank you very much. So I understood now that basically we have to put the AI out in space. It's not enough if we have AI inference here at Earth. Because of a delay, it has to go on spacecraft. It has to go to other planets. So it's becoming somehow our ambassador, our explorer of deep space. Is that fair to say? So is it that first we will send artificial intelligence before we send astronauts? Or do I misunderstand that? Tell me, Matthias.
Well, I think for astronauts, we still have a certain parameter in which we can send human beings. I would say in our lifetime, this is probably Mars. We will not venture beyond Mars with humans, at least not for the time being. And everything beyond that, we definitely send probes out there. And if we can get more knowledge by applying AI technology, definitely that will be used. everything up to Mars, we will send humans with AI, because then we have expert knowledge and the astronaut can perform much, much more tasks and be always like the absolute expert, as if you have a geologist, a medical doctor, and the best engineer in one person combined, hopefully.
Okay, thanks a lot. And I understand we are also sending some new astronauts, even today, into space, right? Bilge, can you tell us a little bit more? Is there something that is close to your heart on that?
Yes, I'm Turkish. I'm from Ankara, from the Middle East Technical University, and we're sending a Turkish astronaut to space for the first time. So we're very excited, along with some ESA and NASA astronauts. The 4 of them are going up tonight, so that's exciting. And I think they're all Europeans. I'm sorry.
They're all Europeans, but some of them are working in Axiom, and
Yes.
they have dual citizenship. Yeah.
Oh, okay.
But the flight is one of them had. But the flight is tonight, and it's really exciting. And I think we share the excitement there.
Yes.
Tonight, European Central Time, and please tune in. It's around 11 o'clock roughly, and it will be a very important mission with Axiom 3.
Indeed. And one of the things that I worry about is radiation in space. I don't think Matthias wants to receive a lot of radiation if you go beyond Mars. Earth is protected by a magnetic field, which we're very lucky for. Mars doesn't have a magnetic field, and well, if astronauts do go there, we'll have to live underground. And it's really hard even to go across to other planets, because really the radiation levels are prohibitive. So one of the things that we're looking at is, for example, in 1840, this will not make Daniel happy at all. There was an event called the Carrington event. Back then, there wasn't much around for electronics except telegraph lines, and the sun made such a big mess that even the telegraph lines caught fire at the time. Now, if this happens, I think telecommunications are out for a bit. So, as well as, well, it's a bit of an electronic doom for Earth, really, and everything with batteries in them. So one of the things that people are looking at is to be able to forecast these events further in advance, because we generally get about 18 hours of a signal once this thing breaks from the sun and hits the Earth. So now AI algorithms, there's just a paper recently, can predict that this thing is actually, before it even leaves the sun, that one of these explosions is going to happen on the Earth, on the surface of the sun. So I think there's a lot of good to be learned from such techniques, and hopefully we can protect Matthias and others better.
Thanks a lot. Anyway, let me ask you. So, how do you feel about now? Very deeply understand humans with AI. Can you trust? You know, we talked a lot about AI as a black box that often we don't understand. We talked a lot this week about explainability. So now, if you feed an AI with all this complex brainwaves information, how can you trust that what an AI tells you really reflects? How do you can basically get this trust into the machine, into the algorithm, even though that at the moment, as we heard, we cannot really explain how it works?
Sure. Matthias, can you take the mic, please? Because I will have a question for you. Throughout the very, very, very selective process that you went through, understatement, did you have to fill psychometric tests, answer questions?
Yes, definitely.
There is more than 40 years of science explaining that those tests are unreliable. Yet...
You're telling I'm the wrong candidate?
No. I'm just saying that the most advanced agencies in their selection process are relying on fiable and proven to be flawed tools. Yes, artificial intelligence has flaws. The outcome should not be taken for granted. But at the very least, it's measuring what the body is experiencing. Let me ask you a simple question. Do you think that in order to understand and monitor Matthias' heart behavior, they used surveys and questionnaires like, hey, Matthias, on a scale from 0 to 10, how tired is your heart? How clogged are your arteries? I don't think they did. So how come they do that to the brain? seriously, the fact that a methodology is worse than the one that I'm promoting is not an argument good enough to embrace and fully trust it blindly. However, the fact that now we have the right sensors that can be miniaturized in order to monitor almost everything that is happening in the brain. I love the example of the retina of the eye. And that AI can make sense of it is providing a level of understanding of physiology and neurophysiology that was never achieved before. Yet, it's not like we're plugging the brain on a machine that says this is what Matthias is thinking or dreaming or expecting. It's just another level of understanding that is going to assist human decision, that is going to assist other artificial intelligence decision like navigation and in crisis management. Because at some point, until you get a good deal of a good deal with NVIDIA and you can bring some GPUs up there, we'll need to have some models that, and that joins what Joseph has been saying, that are prone. What does that mean? Models that function with very little computing power, very little energy, so that they can be efficient and locally executed. This whole ecosystem that is being created now is beneficial for space flights and will benefit humanity at large. But again, this requires, as Joseph mentioned, ethics, doing it in a responsible way. And in order to be trusted, you need human in the mix. And this is not a human protecting the species or trying to make us more relevant. It is just, here we're talking about performance again, sustainable performance, efficiency, effectiveness, and only the combination of humans and artificial intelligence will achieve that, which is what Garry Kasparov, after losing to Deep Blue, called the Centaur model, because he learned from what the machine was proposing and used it in order to beat other players. This is exactly what is going to happen. The future is Matthias with the right tools.
That sounds very good. Does it sound also good from your perspective?
Yes, I think if I can still remain a human being and say like, okay, I still have the right to say like, okay, the proposal from the AI is this, but I still opt for another option, then yes.
Good, thank you. Let me try to summarize a little bit what I learned before I ask the last question. So I understood we have huge potential for AI in Earth observation, and it will make us to understand ourselves and our behavior on a global scale much better. I understood that we learned that AI cannot be just living on Earth, but we have to put it out in space and let it do decisions by itself. And maybe if it's not human critical, it's not involved, it can take decisions by itself. But if it's humanly involved and critical, a human should be always in the loop. And that it also can help us better to understand humans in space. And that it helps us to make Matthias having the right tools, as you nicely said, Olivier. And the last thing that I learned is that it is becoming maybe for deep space missions where we cannot send humans a kind of an explorer, the first kind of explorer that we send out, kind of ambassador for the human mankind on other planets. So the last question that I would like to maybe have a quick answer, maybe from Brian and Joseph, from both of you on this is, so if we are thinking about life outside of our little blue marble, shouldn't we then look for some kind of AI ambassadors from other species? Wouldn't they do then the same? Wouldn't they then also maybe not send first biological, whatever in this terms it means, kind of explorers, but they would send out some kind of AI explorers, or am I completely naive on that?
Okay, easy question. So let's just think what we're trying to do right now. So the Breakthrough Prize Foundation has looked at how do we actually get something to Alpha Centauri, and the answer is we're not sure yet. The idea we came about was to put something about yay big out, power it, accelerate it through lasers. It would have to be essentially some sort of mildly intelligent, the smartest thing you can get in something that big that you could get up to 10% of the speed of light. Takes, let's say, 15, 20 years to get there. It sends something back. So doesn't sound very easy because that's going to be just a shooting star to us, and we will have probably no idea it shot anything back. A bigger machine, which is well beyond what we can do. The interesting thing is we haven't seen anything here on planet Earth. And so unless the AI is a lot smarter than our first versions of AI, it probably has never been here. So that gets to what we call the Fermi paradox, which is if you can send machines, they should probably by now have been able to, over less than 1 billion years, gone to every solar system in the galaxy. Since we haven't seen one here, maybe we're going to be the first ones to do it. But think about how hard it would be to detect what our first AI would be, because it would be tiny.
Joseph, maybe?
I think not much, not much to add. I mean, this is, of course, a very partially philosophical question. It's certainly also a technical one. I approach it more from a probability perspective. I mean, of course, we always believe, and we want to believe, that we are the only thing here on this universe, and nothing else is as smart and as clever as we are, and therefore nobody else would be capable of doing what we are doing. Sometimes the decisions are not so smart, by the way. But if there is some intelligence out there, and that would also try to find us, to come to us, simply the probability is very small. I mean, these distances are so huge, and that at the same time in the universe, which is 13-point-something billion years old, something else intelligent develops at the same very split second, very same moment, and then happens to find us on this very far remote spot in the universe, and that we encounter and can even speak to each other. I think the probability there is very low. Also, the probability that some kind of intelligence is out there may be much higher, or certainly much higher. I think it is something that keeps us busy, keeps philosophies, religions, and many other people very engaged for a very long period of time, including artificial intelligence.
We are really short on time and running over. Olivier, you wanted to say something, but please be brief.
The beauty about humans is that even with low tools, we achieve extraordinary things. And the reason might find some explanation in scientific experiments that showed that we have no free will, but we have free won't. The freedom not to. Exactly what Matthias mentioned. As long as we use technology, and that technology allows the human being to have a last word, we will keep on achieving amazing things up there and down there.
Thank you very much. Let's thank the panel. Thank you very much.